Hello everyone and welcome to Felosoft. My name is Carlos and I'll be showing you very briefly what are roller expressions. Roller expressions are a very efficient and elegant way of recognizing patterns in a text. To test the example, you can go to our website at felosoft.com. At the bottom of the page you will find a download free button where you can get the roller expressions pad. It's very handy and it will let you test all the samples we're going to see here. Roller expression has literal characters. Literal characters are going to be captured exactly as they are. As you see in this phrase, if I were going to find the word test, I go here and let's say the text I want to validate is says something like the test was easy. As you can see, it found a match, test, because it's exactly literal. If I were to use easy, you will find it too. As you can see, it's at the end of the phrase. So whatever test you put here literally, it will match exactly as it is. You have to be very careful because by default, roller expressions are case sensitive. So if I were to use an uppercase Y, it won't match. But we're gonna discuss that in a minute. So for now, let's go to a little bit more special characters. These special characters, we have the most basic ones are the dot, which is going to match any character. The word is going to match any letter. It's alphanumeric, includes letter A through Z, upper and lowercase, numbers 0 through 9, and also the underscore. We have a special character to match the space, the digit or decimal. We have another one for the beginning and another one for the end of the line. If we were to use it in an example, let's say that we want to make sure that the user is entering a valid phone number. And let's say that the phone number, for example, is 626-244-7380, for example. Then using these characters here, we're going to make sure that the user input is correct. So we can use 3 decimals, and let's say anything that goes in between, and then another 3 decimals, anything in between, and 4 decimals. As you can see, it found it. It made sure that it worked. So if I were to use a letter here, it won't match. So I'm checking if a match is found in the form of 3 digits, anything, 3 digits, anything, and 4 digits. Let's talk about repetitions. Repetitions, it means whatever special character that I showed you before, I'm gonna capture as many as I specify here. If I specify the asterisk, it means I'm gonna find 0 or more. If I put the plus, it means 1 or more. The question mark, it means 0 or 1. Exactly n, minimum n, maximum m, and minimum n, no maximum. Let's see that in an example, which is far better. Let's say that I have a sample like I'm gonna match numbers 1 or more. If I put a letter, it will find it. If I put a name, it will find it. It will match. But if I put several numbers, it would match them. Why? Because those are decimals, those are digits, more than 1. It got them all. Let's say I'm gonna use the beginning and the end of the line, which I showed you before. The beginning and end. So basically, what I'm saying here is I'm gonna capture a string that starts, it has 1 or more digits, and ends, like this one. If I were to put a letter in between, it won't match. It's not, a character is not in the list, so it cannot happen. If I put, for example, 7 digits, it means I'm gonna take exactly 7 digits. As you can see, there are 6, so it doesn't match. If I put another one, it works. Another one, it won't. It matches exactly 7 digits. Nothing at the end, nothing at the front, because this is the beginning and this is the end. Let's talk about repetitions. Repetitions, it means whatever special character that I showed you before, I'm gonna capture as many as I specify here. If I specify the asterisk, it means I'm gonna find 0 or more. If I put the plus, it means 1 or more. The question mark, it means 0, 1. Exactly n, minimum n, maximum m, and minimum n, no maximum. Let's see that in an example, which is far better. Let's say that I have a sample, like I'm gonna match numbers 1 or more. If I put a letter, it will find it. If I put a name, it will find it. It will match. But if I put several numbers, it would match them. Why? Because those are decimals, those are digits, more than 1. It got them all. Let's say I'm gonna use the beginning and the end of the line, which I showed you before. The beginning and end. So basically, what I'm saying here is I'm gonna capture a string that starts, it has 1 or more digits, and ends, like this one. If I were to put a letter in between, it won't match. It's not, a character is not in the list, so it cannot happen. If I put, for example, 7 digits, it means I'm gonna take exactly 7 digits. As you can see, there are 6, so it doesn't match. If I put another one, it works. Another one, it won't. It matches exactly 7 digits. Nothing at the end, nothing at the front, because this is the beginning and this is the end. Now let's talk about captures. Captures, basically what it does is when it finds a match, it would keep it stored in a variable or a hold or a place, and then we can use that text, that pattern that we found, we can use it later. Now let's see an example. We have, as you can see here, we have a match. It's gonna be kept in a group that is automatically numbered 0, 1, 2, 3, depending on how many it finds. And then we have a group where it captures an expressions and puts it in a name. Let's see that with an example. If I have, let's say, a date of birth, let's say you have July 15th, 1980. Sorry, I should have put that down here. So we have a date, and then we want to capture the year. Now, if I were going to do that, I would say, okay, 2 digits for the month. I'm gonna get the slash, then 2 digits for the date. As you can see, it's finding it down here. And then let's say I want to go with another slash and then 4 digits for the year. 1, 2, 3, 4. It found it. Now I want to capture it. I would just surround it with parentheses. Basically what it does is that it stores that 4 digits that it found into a group called number 1. If there were more parentheses, like for example here, it would call it number 2. Actually, it starts with 1, with 0, and then 1. But it's not as sophisticated as we would want it to be. So let's say for this same example, we go with a year and we want to put a name to that group. Okay, if I capture a year, I want it to be called year. I will put this. As you can see here, you can put the question mark, the group name between angle brackets, and then the expression you want to match. And this is exactly what I did. I want to capture a group called year, and what I want to capture is 4 digits. So here, as you can see, it matches the whole expression, but at the same time it captures a group, year. If I were going to call this group month, for example, actually this will be day, I'll say this is the day. And here I'm gonna say I wanna capture month. So as you can see down here, it captured the month, day, and year independently. And you have it in groups by name. Right now, you might be wondering what I need that for, but later on, when I'm gonna show you another example in C#, you're gonna see why is that very helpful. Another cool thing about regular expressions is the look around. Basically what it does is that it looks around your expression and it matches it depending on what it comes before or after, or what it doesn't come before or after. As you can see in the 4 lines, the first one is with the question mark equal and then an expression. Basically what it's matching is whatever is in front of it or whatever is before. If you have the question mark less than, equal, and then an expression, which is the second line, is whatever is after or whatever is followed an expression, or whatever has the expression to the left. And the same thing for the not before and the not after. Let's see that in an example so it's easier for you to understand. So let's say in this phrase where I have A, B, C, 1, 2, 3, I want to match anything that is before, I will use the first one, a number. Which one do you think it found anything before a number? Well, C is before a number. Also is 1 and also is 2 because it's before 3, 1 is before 2. And there it is. It found C, 1 and 2. So let's say we want to find something that is, let's say anything that is not after. If you see, it will be the last lane. Something that is not after a letter. Or let's say something is not after Z or Z. So something not after C. Whatever is not after C is A, is B, is 2, and is 3. The only one that is after C is 1. So that's the only one it didn't match. So basically look around, so what it does is that it looks around whatever you put in there. So let's say I want to find any characters that is not being followed by these, or I want to find any letter that is not being after something. That's the way you do it. You look around it. That looks around.